Now we can also add highly customized attribute-driven AOVs as well. This could be useful for a variety of different effects in compositing, or just some more flexible versions of an ID pass where you can get varying values across the surface of one object. So let's minimize that render view and let's go to our environment terrain. Actually, for the sake of this preview, I'm going to go into the environment render object here, and I'm just going to apply some color with an attribute noise. So let's make this element size a bit bigger. And right now this is called CD, the default name for color. But sometimes when I'm working with attribute noises like this, I will leave the noise called CD so that we can see it in the viewport easily here without changing any visualizers or anything. And then if I don't want to keep this attribute named as CD, if I want to call it something else, then I'll just drop in an attribute rename SOP afterwards, so we can rename CD to test adder. So now the color isn't visible on the surface anymore, but if you middle mouse, you can see this attribute is still available on the points there. So now if we go back to the material context and go inside our environment shader here, we can add this extra color-based attribute AOV information. So to add in this attribute-based AOV, let's go over to where the material is connected to this Redshift material node here. Hopefully that's not too confusing. You've got this RS material with all the properties and the Redshift material that gathers various types of information like your basic surface qualities and your bump map and displacement and etc. And we can add in an RS color to AOV, or depending on the type of data you're storing, you could also use the store integer or scalar instead, but in this case it's color information, so I will select that one. And the beauty input for this store color to AOV will be this out color from the material. So wire that in there, and then this out color from this store to AOV will go into the surface input of the Redshift material. And now we can just read in our custom attribute and wire that into this AOV input 0. So let's bring in the attribute with an RS color user data, and that attribute name was test adder. And if you want, you could perhaps add in some sort of a different default value so that this is obvious if it's not picking up the values correctly. So if you just see everything as pure red, that would imply in this case that it's not reading any values from the attribute and that it's just getting this default instead. So you might find that helpful. And then we can connect that output to this AOV input 0 here. And then we can name this AOV. I'm just going to call this the same thing that we called the attribute. I'll say test adder. And then finally on the Redshift ROP, we can write out this data to our AOV. So go to the tab and we'll add an additional one here. Scroll down to the bottom, and I'm actually going to delete this Cryptomat here since I'm not bothering to use that for this project. And for the AOV type, we're going to select custom. And then for the name of this custom AOV, we're going to set the name that we've specified on the shader. So once again, call this test adder and bring back our render view and re-render this. So now if we look at our AOV list, we have a test adder AOV here. And you can see that this is giving us the pure colors of that attribute without affecting any lighting on the surface. So yeah, this attribute is just the raw color stored on all of the different points of this terrain. And this is very useful for perhaps if we wanted to do some particle effects and give particles a custom color to drive various effects that we apply in compositing. Now, these custom attribute-driven AOVs could be used for any of a number of different things. For example, we could also include the mask for the riverbed as an AOV as well, because we have that mask attribute that came from the height field. So maybe you want to do some special color grading just on these walls near the river here, because perhaps, our shader wasn't dark enough or something to represent a wet surface. So if you include that mask as an AOV, that gives us a whole lot more control in compositing without changing the shader and re-rendering our entire image. And actually, instead of just talking about it, let's actually go ahead and add that mask as an attribute as well. I'll go back to our render object here. Let's make sure that mask is available. And sure enough, we have this mask here, and this is just a float value. That's not a color. So back on the shader, we can store this as a scalar instead of a color. So go back inside the RSENV, and this time I'm going to store a scalar to AOV, and we'll drop this in between the previous AOV and the Redshift material here. And let's read an RS scalar user data, and the attribute that we want to read in is called mask, and we'll wire that into the AOV input here, and we'll give that the name mask. And then back on the Redshift render ROP, we'll add another AOV here. Once again, this will be custom, and I'll set the name to what we've specified in the shader, which is mask. And rendering this once again, if we select the mask from our drop-down of AOVs, you can see we now have a pure AOV channel just for those masked out regions representing the walls of this riverbed terrain. So yeah, feel free to experiment with these and add any additional passes that you might find useful for finessing the image after rendering it. Although for this project, I did keep it pretty simple and compositing because I was actually pretty happy with the raw renders that I was getting without a whole lot of finessing in post.